Hello everyone. Hello Maker Faire Rome. Last year I had the great privilege to go and make a presentation in real life at Maker Faire Rome in October. And of course this year it's all virtual. It looks like quite a good program. And I want to tell you today about electronic music keyboard that I've been working on for quite a while. Let me just get started here. So I'm going to basically go through, give you some of the history. I want to spend some time taking you through some of the components. This is the second version. I did give a talk about the first version at Virtually Maker Faire in April, which is on my website. But in this case, I want to show you the changes and the improvements I've made since then. So first of all, why did I do this? It's a very good question. So just a minute, let me get organized here. And oops, all right, how to waste time. So first of all, I've always wanted a keyboard for electronic music that is not a piano keyboard. And if nothing else, by the end of this presentation, you'll understand why it's not, I don't want a piano keyboard. And so I tried over the years. I guess I've been experimenting with electronic music since I first started working, which I won't say how many years ago that was. And over the years, I've tried a number of commercial versions of it. For example, this is something called a jam stick, which is a sort of a small electronic guitar. And it was kind of neat, helped me get back into playing guitar again, but it really has a lot of shortcomings. And one of the things that this is a problem with this is it uses Bluetooth to talk to the computer. And as a result, there's long delays from the time you pluck the string to the time you get the sound. It's probably not that long in terms of measured terms, but it's something that's really noticeable. So anyway, I've been toying around with this for quite a while. And then a number of years ago, I went to one of my favorite pop artists' concerts. And her name is Basha Bulat. She's from Ontario. And as you can see in that photograph there, which I swiped from a YouTube video, she had some kind of a switch box. And it was basically a looper, and she was able to basically change the key of the looper. So this got me thinking, could you make something that was more general purpose and different than that? So how about that for using switches? I thought, well, that would give you the individual notes, but you'll see it looks surprisingly like a piano keyboard. So this was going nowhere. Then I wondered about the hurdy-gurdy. And actually, after Maker Faire Rome last year, we went to Florence and we went to the museum where they have the music instrument exhibit, and these are two hurdy-gurdies from the 1700s. It's an interesting instrument, and it is have the advantage of being different and portable, but it's not very general purpose, and it's a little bit too exotic. So a few months, I guess, after I got back from the Maker Faire, I just happened across a YouTube artist. Her name is April Young, and she's created an instrument called the kalimba. Actually, the kalimba is it's a derivative of an ancient African instrument, and it's sometimes called a thumb piano. And anyway, she's redesigned this and made it easy to manufacture. And she's also she's got a great YouTube channel, and she teaches how to play it. people how to play it. So I think you can see the resemblance to the EMMMA-K there. And that certainly was an inspiration. So before I get into how this actually works, and let me just give a little bit of a background. So first of all, electronic music is something we hear all the time, but I just want to clarify that what I mean by electronic music is that it employs electronic musical instruments, digital instruments, or circuitry-based music technology, and that's right off Wikipedia. So that means no acoustic, no mechanical devices, except for the keyboards, of course. And so that's what I mean by electronic music. Of course, there's traditional music synthesizer. This is a Moog synthesizer from, I think, the 80s, and is actually a wonderful device. You can actually still buy Moog synthesizers today. Just to give you the background of it. So usually when the more traditional synthesizer has everything all in one, usually the keyboard and the electronics, and it's a complete standalone device. And Yamaha made this very popular over the years with their DX series of keyboards. So digital, if you use a computer, then you have to run software on it. What I'm showing you here on the screen is that same dreaded keyboard again, and my MacBook Pro running GarageBand in this case. And GarageBand actually comes with Mac OS. It's just part of the software suite that comes with it. MacBooks are very popular with musicians, especially musicians that do electronic music. So it's fairly natural to use it there. It does work on Windows and on desktop PCs as well. So MIDI is the way these things are talked to each other. So that's a musical instrument digital interface, and it's a protocol and a set of digital interfaces that allow these devices to talk to each other. It was proposed in 1981 and has become the standard for how all instruments talk. So rather than make a standalone device like a synthesizer, I decided to follow the same approach. Whoops. And so again, I'll use the digital audio workstation. In this case, today I'm using GarageBand, but I also have Ableton Live. I just don't have much experience with it, so I don't use it for demonstration purposes. So this is the first version of the EMMMA-K, and one of the key things about that I wanted to achieve was very low latency from the time you touch the key to the time that you hear a sound. And in fact, something as little as 20 milliseconds, 20 thousandths of a second, can be noticeable by a trained musician for sure, maybe even less than that. So I decided that I also decided that I wanted to use touch keys, and touch keys and that's the most critical part of this to get right for usability. And I'm going to show you now the components and what I mean by this. And this first version of the EMMMA-K was simply, once I got far enough that I thought it was going to work, I threw this together in an afternoon. And as you can see, it's just brass wires punched into an old cardboard CD case. But it turned out to be amazing how effective it was. So, components. Let me see here. Right. Almost every microcontroller, and that one's called the Teensy that I'm showing there, is capable of having touch input. So a touch pin is the same kind of thing as a touch screen, except that it's on a piece of wire of some kind or a plate that you touch. And I think we're all familiar with that in devices. And most modern microcontrollers, including Arduinos and a whole host of others, have the capability to attach a wire to one of the keys and one of the pins and be able to touch it and turn it on. So I've had a lot of experience with this particular family of microcontrollers, and one of the things that that's really unique about the Teensy is that it's capable of transforming itself into a USB MIDI device, which is something that is not usually accomplished just with a single component. So it turns out that the Teensy also has very good touch pin performance. So, and I guess the third unique advantage of it is that it's very low cost. It's about $20 Canadian and readily available. So I just want to see, how's my time? Okay, doing pretty good. I want to I'm going to do a little show and tell here now. There we go. So here's the Teensy, taking it right out of the box. Pretty sure we can see that okay. And you plug it in. You can see how teensy it is. And what do you get? Blinky. This is the hello world of microcontrollers. First thing anybody does to test a device, blink the LED. It's also a good tool as you progress to tell how your software is working. So let's just get rid of that one. And here's one with some connectors on it that whoops, hope you didn't get dizzy. Here's some with some connectors on it that we can attach some test pins to. So this is actually from the first version of the EMMMA-K. So we got here is some touch pins. So it's just a piece of brass wire and it's got a little connector on the end. And I'll plug that into here. See? I touch the pin, the LED goes on. Even just from that, I think you can see the response of it. It's very good. Of course, I did a lot of testing and measured this. Did lots of tests and measured it to actually get and figure out what the latency is, and it's very low. These are bare wires, which is not recommended. It turns out that you can use what's magnet wire, which is insulated wire, and it works just fine. So, as well as capable hardware, we need software libraries to go with it. And one of the great things about this particular microcontroller is it's got a huge and enthusiastic following of electronic experimenters. And there is tons and tons of freely available software libraries to use with this. For example, the touch pins, the performance of them was created by someone who's probably spent an awful lot of time writing that software library. So that, gives you the opportunity to put these pieces together and actually accomplish what you set out to accomplish. And quite often you go down the wrong road, but anyway, let's move on. I see I'm going to run out of time. So the other component in the version 2 of the EMMMA-K, is this neat little computer here. This is called the, oh, hold on, it'll come back to us, the M5 stick. And it's from a little company in Shenzhen, China, who I've used a lot of their stuff and actually got to meet them at a Maker Faire a couple of years ago. Anyway, one of the things that you can see here is really unique. As you see, as I tilt the device, you can see the object in the display rotating. We'll come back to that later. That's very important as well for what I was trying to do. So, what else have we got here? The other thing, the third component on here is this rotary encoder. So it looks like a potentiometer, but in actual fact it generates pulses and it rotates continuously. So we're quite used to seeing these controls now on volume controls in your car and things like that. The other thing that it has is a switch here. When I can push this switch and I can detect that in my computer. Okay, so let's go back to this one. So, what are the features of version 2 of this? First of all, there's the display here. I 3D printed the case. It fits just nicely on a small 3D printer bed. And here's the rotary encoder. So I also added out, I think it's time to actually try it. So I've got it tuned to the key of C major. And let me go back and put a different instrument on. Let's try something interesting. So, let's try C minor. Actually, there are 19 separate keys in here. Whoops, sorry. They're all 12 keys. There are 19 scales. A major scale, minor scale, pentatonic. So, anyway, oh yes, and the other thing that this can do is it has what's called pitch bend in. So that's how the little accelerometer in the M5 stick is producing that, giving us that information and cause that. So this gives you much more versatile keyboard. Yeah, let's see. Oh yes, I should mention the whole cost of this device now is less than $100, $100 US. So I was going to do, I am running out of time. So I was going to do a little bit of music theory here just to show you how versatile this device can be. But I'm just going to mention that the kalimba itself, of which I have one here, is tuned to the C major scale. So that may seem very limiting especially from say a piano keyboard's player perspective, and that's why I gave all these different scales and put them in, and that's the beauty of an electronic version of this device. And let's see. Yeah, I want to leave 10 minutes for questions. Let me just see what our audience is. Well, people stuck with me. That's a good sign. Anyway, we'll just spend for those not really familiar, with what a digital audio workstation can do, I just want to show you that I can generate the sounds completely electronically. So let's do something unique like a cathedral organ. And let's go down an octave. Let's enable some. Right now I filter out adjacent keys because it's easy to, if you're trying to play a scale or something like that, it's easy to hit adjacent keys, but for doing chords, I allow them. And discords as well. So, have you ever heard an organ do a pitch bend? So, it's the beauty of being all digital. Well, let's see now. I think I will just spend just a minute just to emphasize again the value of having the different scales. Let's go back and just do the major key again. There we go. All right, just a do, re, mi. So that's C major. And that's just the C major triad. That's a C major chord, okay? So, minor. And the C minor chord. Anyway, you can't do that on a kalimba. So that's one of the unique things. So my conclusion, is this worthy instrument for a musician to play live? I really don't know. But it certainly scratched my itch for what I wanted, and I certainly have fun playing with it. And maybe someday I'll learn how to really play it. What I plan to do next is, one thing I really like to do is spend more time with Ableton Live. I do have a standard license for it. And with Ableton Live, I'll be able to change instruments directly from the device. And that's probably the only thing I have planned. Oh, the other thing would be to record a loop. In other words, record a sequence here, and then be able to touch a key and have that continue on its own, switch to another track which would contain a different instrument, play a second track, and the whole thing could be automated right from this keyboard. As you can see, this is pretty small. It will play with an iPad or even an Android device if you have the right adapter. So it's the kind of thing that I used to take that jam stick when I traveled for work, so I could keep my guitar practice up, but this is something that would be interesting to take with you when we ever get to travel again. And yes, that's it. So now I'm going to look to see if there's any questions here. And okay, Francesco asked me, is software and hardware open source or can it be downloadable? I will plan to publish this on GitHub, which is the vast repository of all open source software, and it will be readily available. I'll put the files for the 3D printed box, and that'll probably be a week or two before that. And Gary asked me, can you hook the EMMMA-K to a launch pad or other devices like synthesizers? Right now, this supports USB video out, USB MIDI out. it could be adapted to take something like a launch pad, but it would be better to hook the launch pad up separately to your digital audio works, to your DAW, and use it to control the DAW as opposed to control the EMMMA-K. And Gary also asked, can you loop on it? And as I said, I think you asked that before I gave my answer in advance. Anyone else have any questions? And let's see if that's Q&A. And nothing in chat, I don't think. Oh, where are the sounds coming from? Aha! So the sounds are coming from... Yeah, humbug. GarageBand, playing on the music. So, or playing on my MacBook. So, for example, if I pick a new instrument here, I just switch to saxophone, for example. Then, so I can play a saxophone. And there's something like 600 instruments in different instruments in GarageBand, but some of them have some really interesting effects. For example, this one. Any more questions? I'm determined to finish this on time. And thanks for Francesco, for joining from Italy. It's late there. It's 10 o'clock. And anyway, I think we'll just, rather than me just jabber on, I think we'll end the stream. Thank you everyone for attending. I really appreciate it. And I hope you enjoy the rest of the Maker Faire Rome, and maybe we'll all meet there in person again next year. Would be really nice. So goodbye and have a good evening and a good weekend.